Good morning, students. Today I am going to discuss a problem for you. Let's read the question first of all. Figure shows a spherical conducting shell. A charge Q is placed at its center. Find the charge appearing on each surface of the shell. Hope you can read the question. The same is shown in the figure. Charge Q is placed. This is a conducting shell. This is an important word to be noted. It is a conducting shell. Conducting. The shell is a conducting shell. This is an important point to be noted in the question. Okay. When you see the word conducting, what will be the first idea that will come into your mind? What is going to be the first idea that is going to come in your mind? The idea that will come into my mind is the electrostatic field is zero inside a conductor. Electrostatic field is zero inside a conductor. I'm going to take a point P inside this conductor. Straight away I can say the electrostatic field at a point P inside the conductor is equal to 0. Okay. This is what you have to say inside a conductor, or you have to understand inside a conductor. Very, very important point. Okay. What to find out in the question? Charge appearing on each surface of the shell. Charge appearing on each surface of the shell. I don't know the answer. Okay, so pause the video for a minute and just try to find out the answer. Okay, let us assume charges Q1 and Q2 to be present here. Q1 and Q2 are the charges present here. From the conservation, I hope you can see from here, from the conservation of charge, Q plus Q1 plus Q2 is equal to 0. Sorry, Q. Because total charge of an isolated system should remain a constant. That means Q1 plus Q2 is equal to 0, or Q1 is equal to minus Q2. So this is an important idea to be taken into consideration. Okay. So the next thing I'm going to keep in, or I'm going to consider is, I'm going to consider a Gaussian surface. I'm going to construct a Gaussian surface and I'm going to apply the Gauss's law here. What is Gauss's law? Closed integral EP dot ds is equal to 0. Q in divided by epsilon 0. Closed integral EP dot ds is equal to Q in divided by epsilon 0. Now let's substitute here. What is the value of EP? 0. That means there is no significance for the left side of the integral. That is already equal to 0. Which is equal to right side of the equation, which is Q in divided by epsilon 0. I am not going to write epsilon 0. Okay, now look at the figure please. What is Q in mean? Charge enclosed by the Gaussian surface. Look at the figure and tell me what is the charge enclosed by the Gaussian surface shaded in green. Tell me the charge enclosed by the Gaussian surface. Yes. Q plus Q1. That is equal to Q in. Already we have seen it is equal to 0 here. Now I am getting the value of Q1, right? What is the value of Q1 is equal to minus Q. Q1 is equal to minus Q. I got the answer. Then what is Q2? Q2 is equal to, you can see from here, minus Q1. Minus Q1. Already Q1 is equal to minus Q. So the answer will be equal to plus Q. Which means the charge appearing on the inner face of the conductor shell will be minus Q, and the charge appearing on the outer face of this one will be plus Q. Okay, second question. Figure shows two concentric spherical shells. The inner shell is charged to Q. Find the charges appearing on surfaces 1, 2, 3 and 4. Assume conducting. I have labeled the spheres by names A and B. Both are conducting spheres. Conducting spherical shells. Spherical shells. Conducting spherical shells. Okay. What we will do then first? As we got the name conducting, the most important point we will write is electrostatic field is 0. Where? Inside the conducting sphere. I'm going to take the first shell now, shell A. So to tackle this kind of problems, you are only to look at two steps. One is to apply Gauss's surface, second one is Gauss's law, and second one is to use the conservation of charge. I'm going to draw shell A. As it has got two surfaces, I will differentiate it by considering some thickness. As it is magnified here, that is the reason why it shows likewise. Surfaces 1 and 2. As I said, to tackle this kind of questions, our first step is to consider a point inside the conducting part. What is the electrostatic field at the, okay, I will label it by the name P. What is the electrostatic field at the point P? Hope you will easily answer that question because the answer is 0. Let's assume that the charge on this surface is Q1. Charge on this surface is Q2. So step 1 I said, electrostatic field at the point P is equal to 0. The second point is conservation of charge, that is Q1 plus Q2 is equal to, what is the charge on the surface of sphere? Is Q. So Q1 plus Q2 is equal to Q. Q1 plus Q2 is equal to 0. I'm sorry, Q. The next point, as we said, we have to use is, at any point inside a conductor, the electrostatic field is 0. Applying Gauss's law, closed integral EP dot ds is equal to Q in divided by epsilon 0, that is already equal to 0. That means Q in is equal to 0. Look at the figure, children. What is the charge enclosed by the so constructed Gaussian surface? Charge enclosed by so constructed Gaussian surface. Please get me the answer. This answer. Look at this figure. It is Q1. Straight away we have got the answer to part 2. The charge on the surface one, which is Q1, is equal to 0. Q1 is equal to 0, I got. Since Q1 is equal, this is equation number 1 I am putting. Now this is equation number 2. I got Q1 is equal to 0. Once I got Q1 is equal to 0, what I need to find out next? The value of Q2. That is very simple. You can easily find it out. What's the answer going to be? Q2 is equal to Q. Once Q1 is equal to 0, then I got Q2 is equal to Q. So this part is over. This part is over. What next? Next is part 3 and 4. On the surfaces 3 and 4. Okay, will you help me? Just like I considered here. Okay, I'm just removing this figure. And I would say this is shell B. I will construct shell A also. Shell B, now I am considering in a, just like we did in the previous problem, this is shell B, taking a point R here. Now it's all easy. This is the charge on this surface is 0, the charge on this surface is Q. The charge on this surface I am taking Q3, the charge on this surface I am taking Q4. Right, again it's an isolated system, and what do you know about an isolated system? Total charge is equal to a constant. So using the conservation of charge, the first point I'm going to write is, this is 0, 0 plus, come on, Q plus, Q3 plus, Q4 is equal to, this is the total charge on each surface of the spherical shells. According to the conservation of charge, the total charge on the system should be a constant or should remain conserved. What is the initial charge on the system? Q. What should be the final charge on the system? That also must be Q. So this is Q itself, which implies Q3 plus Q4 is equal to 0, or Q4 is equal to minus Q3. Q4 is equal to minus Q3. Yes, that part is over. What next? Applying Gauss's law. What is the Gauss's law? Closed integral ER, because I am taking a point R inside this conducting sphere. So closed integral ER dot ds is equal to, we will straight away write one of the charges enclosed by this Gaussian surface. Okay, I'm sorry. Let me draw the Gaussian surface. Tell me quickly, what are the charges enclosed by this Gaussian surface? Yes. 0, Q, Q3, right? Charges enclosed by this Gaussian surface. Charges enclosed by this Gaussian surface. Yes. It's very simple to solve. This is Q plus Q3 divided by epsilon 0. Hope you understand that. But what is the electrostatic field at R? Electrostatic field at R. Electrostatic field at R. It is inside a conductor. What is the electrostatic field inside a conductor? Come on. What is the electrostatic field inside a conductor? 0. So ER is equal to 0. What is the left side of this equation equal to? 0. What is then Q3 is equal to? Q3 is equal to minus Q. Q3 is equal to minus Q. Therefore, sorry, this is the symbol of sins only. Therefore, what is going to be Q4? Q4 is minus Q3. Q4 is equal to Q. Q1 is equal to 0. Q2 is equal to Q. Q3 is equal to minus Q. Q4 is equal to Q. So shall we make it final? Hope you understand this problem. So let me remove this figure because of the space constraints. This is shell A. This is shell B. Charge on this surface is 0. Charge on this surface is Q. The charge on this surface is minus Q. Charge on this surface is plus Q. And this is finally the answer. Hope you understand this. Now I will modify this question for the next one. Okay, only one modification. That modification is, as you can see, I just erased a word here. Instead of inner, I would now say outer. Now you can read the question. Figure shows two concentric spherical shells. The outer shell is charged to Q. Find the charges appearing on the surfaces 1, 2, 3 and 4. Assume conducting. It's a simple question for you. May I draw the figure, please? Shell A, shell B. This carries a charge Q. What are the charges appearing on the surfaces 1, 2, 3 and 4? Again, what is the procedure to solve this kind of questions? I told you, step 1, electrostatic field inside a conductor is 0. Second one, the total charge of an isolated system is a constant. Okay, we will take the shell A now. For our knowledge, I will make it, although this is shell, this will have some kind of thickness that I will take into consideration. Shell A is taken into consideration. So this is surface 1, this is surface 2. Surface 1, surface 2. What is the total charge on shell A? Q1 plus Q2. But where is the charge given? It's given on the outer surface of the sphere, right? That means what is the charge on the inner shell? 0. There is no charge here. No charge here. Inner shell does not contain any charge. So Q1 plus Q2 is equal to 0. Now taking a point P inside this one and applying Gauss's law, the process is now very simple only. What is closed integral EP dot ds is equal to charge enclosed by the Gaussian surface, which is Q1. This is Q2. Q2 is outside the Gaussian surface. The charge inside the Gaussian surface is Q1. So this is going to be Q1 divided by epsilon 0. But this is already equal to 0. The math is easily done. Q1 is equal to 0. Once Q1 is equal to 0, what is going to be Q2? This is 0. Then what is going to be Q2? Q2 is also going to be 0. The charge on surface 1 is 0. Charge on surface 2 is also 0. That's way so simple. How we got this answer? Q1 is equal to 0. Q2 is equal to 0. If you give a charge on the outer sphere, no charge will appear in the on any surface of the inner shell. Simple. Now take the second part. Let's take the shell B. Again, I am making it thick for the understanding purpose. This is surface 3 of the shell. This is the inner surface of shell B, and this is the outer surface shell B. Now, just like we did earlier, we will take a point R inside this shell B, and we will construct a Gaussian surface. We will construct a Gaussian surface, and directly we can write Q1 plus Q2, total charge on this system. Q1 plus Q2 plus Q3 plus Q4 is equal to 0. If I say so, you will say, sir, you are wrong, because the system has got a charge Q. So this is Q. Already we got Q1 is equal to 0, Q2 is equal to 0, which means I can write Q3 plus Q4 is equal to Q. Now we need to find out the value of Q3 and Q4. That is charges on surfaces 3 and 4. How to solve it? Very simple. Apply. Gauss's law. Closed integral ER dot ds is equal to charges enclosed by the dotted Gaussian surface. Tell me, that is Q1, I think that is inside only. Q2, that is also inside. Then Q3, that is inside. What about Q4? Charge on the surface 4. Is it enclosed by the Gaussian surface, or is it outside the Gaussian surface? Look at the Gaussian surface, and surface 4 is outside the Gaussian surface or inside? I think it is outside, right? This is Gaussian surface, and surface 4 is outside the Gaussian surface, so I need not write Q4. This is already divided by epsilon 0. But what is ER equal to? We know it. ER is equal to 0. ER is equal to 0 means right side of the equation is equal to 0. But what is Q1 equal to? Already we got that 0. Q2, 0. Q1 is equal to 0. Q2 is equal to 0. Now what is going to be Q3? What is going to be Q3? It's very simple now. Q3 is equal to, yes, 0. Q3 is equal to 0. Which means, okay, I got Q3 is equal to 0. Now what is going to be Q4? What is going to be Q4? Q4, value of Q4. Q4 is equal to Q3 0. Q4 is equal to Q. The problem is over. Q1 is equal to 0. Q2 is equal to 0. Q3 is equal to 0. Q4 is equal to Q. That means will there be any charge redistribution in this case? Inner shell will remain to be likewise only. The charge will remain to be on the outer shell itself. That's what you can see from here. Q1 is equal to 0. Q2 is equal to 0. Q3 is equal to 0. Q4 is equal to Q. Hope you understand these problems clearly. Now, will you suggest a method? Will you get me the answer? Now I'm going to take the learning into another question. So figure shows two concentric spherical shells. The inner shell is charged to Q1 and outer shell is charged to Q2. Find the charges appearing on each surface of the conducting shells. Each surface of the conducting shells. Look at the question once more. Figure shows two concentric spherical shells. The inner shell is charged to Q1. The outer shell is charged to Q2. Find the charges appearing on each surface of the conducting shells. It's a very simple job only. Inner shell is charged to Q1. Outer shell is charged to Q2. And they are placed concentrically. And what you have to say is charges appearing on each surface of the spherical shells. Very simple job now. Let's take this charge on this one as Q1 dash. This is Q2 dash. This is Q3 dash. This is Q4 dash. Can you directly say what is the value of Q1 dash going to be? It's very simple. Q1 dash. What is going to be Q1 dash? Okay, what is Q1 dash plus Q2 dash is equal to? This is an isolated sphere. That is going to be equal to Q. Q1 dash plus Q2 dash is equal to Q1. I'm sorry. Now, what is the electrostatic field at any point P inside this shell, inside the conducting part of the shell? It is 0. So, I will use the formula EP dot ds. So, I have taken this shell to be, with your permission, I am making it pick inside here itself so that I could take the point P inside this one, applying Gauss's law by constructing Gaussian surface. Inside is Q1 dash. So EP dot ds is equal to 0. The charge enclosed by the Gaussian surface is Q1 dash divided by epsilon 0, which means Q1 dash is equal to 0. I got Q1 dash. Once I got Q1 dash is equal to 0 implies Q2 dash is equal to Q. Q2 dash is equal to Q. Now taking the next surface, again I am making it sufficiently thick. This is surface 3. Again I take a point R here. This charge is Q3. Using the conservation of charge, Q1 dash plus Q2 dash plus Q3 dash plus Q4 dash is equal to the charge given to this was Q1. The charge given to this was Q2. So that means charge on the system. Initial charge on the system. How much is initial charge on the system? Charge on this one is Q1. Charge on this one is Q2. So charge initially on the system was Q1 plus Q2 according to the conservation of charge. The total charge initially on the system will remain to be the total charge finally on the system. That is conservation of charge for an isolated system. Isolated means non-interacting. In the pocket, I have got some money with me. If I am not using it for any purpose, myself is an isolated system. Neither I am not using my money and I am not gaining any money from others. I am not interacting with anyone else. So just like that way, this is also an isolated system. The system involving two spheres, two spherical shells. Now, this is not an isolated system. This is not an isolated system, but their combination is an isolated system because they are not interacting with anyone else. That's the reason why these two becomes an isolated. Please bear that in mind. Isolated system. Now, I can say total charge on the system is Q1 plus Q2. Finally, this is the charge. Already we got Q1 dash is equal to this thing. Now I can say Q1 dash is equal to 0, Q2 dash is equal to Q1. Q2 dash is Q1, not Q. I'm sorry. Just substituting for Q1 dash here I got Q2 dash is equal to Q1. Which means Q3 dash plus Q4 dash is equal to Q2. Ready? Q3 dash plus Q4 dash is equal to Q2. Now what is our next step? As we did in both the problems discussed, I have to apply Gauss's law. For that I have to construct a Gaussian surface. Construct a Gaussian surface. After constructing the Gaussian surface, the next job is yours. Tell me. So closed integral ER dot ds is equal to ER dot ds. That is Gauss's law. Now the right side of the equation, denominator is epsilon 0. What should be the numerator? Charges enclosed by the Gaussian surface. Which are they? Q1 dash plus Q2 dash. Now then you may be asking a question, sir, should I take this Q1? I'm sorry, this Q1 is just to show that it was the initial charge on the system. Q1 dash, Q2 dash, Q3 dash, Q4 dash are the final charges appearing on each surface. Q1 and Q2 are initial charges on the surface. Don't mix them with it. Q1 and Q2 are the initial charges on the spheres. As a result of their reorientation, this will get redistributed as Q1 dash, Q2 dash, Q3 dash and Q4 dash. Hope that will be clear to you. Q1 and Q2 are initial charges on the system only. So this is Q1 dash plus Q2 dash plus what? Charge enclosed. That also Q3 dash, right? That should be equal to 0. Why 0? Because ER is equal to 0. Why ER is equal to 0? Because it's a conducting sphere. It's a conducting shell. And electrostatic field inside a conductor is 0. Electrostatic field inside a conductor is 0. That you have learned in yesterday's class, don't you? That's the reason why I say ER is equal to 0. Now what is already Q1 dash is equal to 0. What is Q2 dash? Q1. Now which will give you Q1 plus Q3 dash is equal to 0, which implies Q3 dash is equal to minus Q1. Q3 dash is equal to minus Q1. Q3 dash is equal to minus Q1 means I can substitute in this expression. So substituting. So this is equation number 1, this is equation number 2, this is equation number 3, substituting 3 in 4. Substituting equation 3 in equation 4 we get Q4 dash is equal to Q2 minus Q3 dash, which is equal to Q3 dash is minus Q1, which is Q2 minus Q1. What is minus of minus? Plus. So I would say this is plus Q2 plus Q1. That means I am getting Q4 dash is equal to, with your permission I am writing here, Q4 dash is equal to Q1 plus Q2. Q4 dash is equal to Q1 plus Q2. That is the answer we are getting. So finally we are at the conclusion of this problem. Charged, initially charged spherical shells. I have to say the inner shell is initially. I'm sorry to say this. Word should be there. Initially charged. Outer shell is initially charged. Okay, even if that word is not there, doesn't matter. It means initially they have the charges likewise. What are the charges appearing on each surface? Q1 dash is a charge on the inner surface is 0. Charge on this surface is Q1. Charge on this surface is minus Q1. Charge on this surface is Q1 plus Q2. Let us conclude by redrawing the figure. This is inner shell, this is outer shell. The charge on this one is 0. Charge on this shell is Q1. Charge on this shell is minus Q1. Charge on this surface will be Q1 and Q1 plus Q2. Hope you understand these questions.